Welcome to educator.com. In this lesson, we're going to continue using the Pythagorean theorem. In this lesson, we're going to learn about using different forms of the Pythagorean theorem in order to find lengths of legs. Previously, we learned to find the hypotenuse. Also, we're going to use the Pythagorean theorem to determine whether a triangle is actually a right triangle. Applications would be designing structures like ramps and bridges. Vocabulary for this lesson includes knowing about the Pythagorean theorem. In any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So for example, if you have a right triangle, which is a triangle with a 90-degree angle, the legs are usually represented by A and B and the hypotenuse by C. So the sum of the squares of the lengths of the legs. So if you take the length of the leg, A, and square it, and B and square it, and sum them up, it will equal the square of the hypotenuse, C squared. So this leg squared plus this leg squared will equal this leg squared. Let's try using the Pythagorean theorem to find the length of a leg. A 30-foot ramp leading into a truck forms a right triangle with the ground. The base of the ramp is 24 feet. How high is the top of the ramp? In a problem like this, it's very useful to draw a diagram. So we have a 30-foot ramp. It's leading into a truck. And it forms a right triangle with the ground. So here's our 30-foot ramp, and the base of the ramp is 24 feet. And we want to know how high the top of the ramp is, where the truck is sitting. This is our truck. All right, so we're looking for our leg here. What we have is one leg value and the hypotenuse value. So by using a squared plus b squared equals c squared, let's substitute some values. We can use 24 as one of the legs, so 24 squared. We don't know how high the ramp is, and this could be our b, plus b squared equals 30 squared. Remember that the legs are interchangeable in the formula because commutative property tells us that this order can switch. Adding numbers can be switched. So 24 times 24, I'm going to go about solving for b now. 4 times 4 is 16, 8, 9, hold the place, 8 and 4. 6, 17, and 5. 576. 16, 8, 9, okay. Plus b squared equals 30 times 30. You can say 3 times 3 is 9 with 2 zeros. So now I'm going to solve this equation by subtracting 576 from both sides. This cancels out to 0 and we've isolated the b squared. 900 minus 576. 10 minus 6 is 4. We borrowed, so 9 minus 7 is 2. And we borrowed, so 8 minus 5 is 3. b squared equals 324. Remember that the ramp is not 324 feet high. We still need to find the square root of b, or the square root of 324. We could do an estimation here to find where we're close to. Well, we know that 24 times 24 is going to give us 576, which is much too high. So let's try maybe 18 times 18. I'll give us 6, 8 plus 6 is 14. Hold the place, 8 and 1. 4, 12, 324. Good, so we found the right number. So the square root of 324 equals b, which equals 18. So this side here is 18 feet. Let's see if it makes sense. Remember that in a right triangle, the hypotenuse must be the longest side. So yes, 30 feet is the longest side when compared to 18 and 24. Let's try another ramp problem. A 14-foot ramp forms a right triangle with the ground. So the ramp is 14 feet high, or 14 feet sloping, and the base of the ramp is 13 feet. How high should this platform be? So this would be my right triangle here. Okay, so we're looking for the height here. So let's say a squared plus b squared equals c squared. That's our starting ground, our Pythagorean theorem. A we can call either leg. We'll say that 13 represents the first leg. The second leg is what we're looking for, and we know the ramp is 14 feet, the sloping ramp squared. 13 times 13 is 169 plus b squared equals, let me do 14 times 14, I don't remember off the top of my head here. 4, 5, hold the place, and 4 and 1, 6, 9. So 196. So now to solve for b squared, I'm going to subtract 169 from both sides so that I can isolate the b squared. This goes to 0, so I have b squared alone equals 16 minus 9 is 7. I borrowed, so 8 minus 6 is 2. So b squared equals 27. Well, 27 is not a perfect square. So instead of giving an inaccurate answer, let's just say b equals the square root of 27. Determine whether the given lengths can be sides of a right triangle. Explain. Well, let's use our Pythagorean theorem. A squared plus b squared equals c squared. We remember that the hypotenuse is the longest side. So out of 8, 12, and 15, which one's the longest? 15 is. So that's going to have to be our hypotenuse. So 8 and 12, we can interchange. It doesn't matter. The legs can be interchangeable. So 8 squared plus 12 squared should equal 15 squared if this is a right triangle. Because remember, the Pythagorean theorem only works for right triangles. 8 times 8 is 64, and 12 times 12 is 144, and 15 times 15 is 225. Let's check out our work. 144 plus 64, 8, 10, 208. Do they equal? No, that does not equal. So are the given lengths the sides of a right triangle? No. And let's explain. We can say because the legs squared do not sum up to be the hypotenuse squared. Could start the sentence with a capital here. You could also say no, because 64 plus 144 does not equal 225. Let's try this next one. In looking at 3.5, 4.5, and 5.5, I'm going to call my hypotenuse 5.5 because that is the longest side. So 3.5 squared plus 4.5 squared should equal 5.5 squared if this is a right triangle. 3.5 times 3.5 is 15, 16, 17, hold the place, 15, 9, and 10. 5, 12, 2, and 1 with 2 decimal places. So 12.25 plus 4.5 times 4.5, 25, 2, 22, hold the place, 20, 16, and 18. 5, 2, 10, 20 with 2 decimal places, 20.25. And 5.5, 25, 27, hold the place, 25, 27, 5, 12, 10, 3, 2 decimal places, 30.25. So 12.25 plus 20.25 equals 32.50. And once again, no. Because 3.5 squared plus 4.5 squared does not equal 5.5 squared. Let's find the missing leg length. If necessary, we'll round to the nearest tenth. So they give us a squared. We're probably looking for b squared here because I don't see it in the information. And they give us c, and we'll be able to square that. So we're going to have 13 squared plus b squared equals 18 squared. 13 times 13, 9, 3, 0, 3, 1, 9, 6, and 1. 169 plus b squared equals 18. 18 times 18 is 64. 6 plus 8 is 14. Hold the place 8 and 1. 1, 2, 3, 324. Now we're going to be solving for b squared. So to isolate the b squared, let's subtract 169 from both sides. B squared equals 14 minus 9 is 5. We've borrowed. 11 minus 6 is 5, and we've borrowed. So 2 minus 1 is 1. So b squared equals 155. Well, I know that 155 is not a perfect square, but in this case, it asks us to round to the nearest tenth. So let's find the square root of 155 to the nearest tenth. You would want to use a calculator here, and without a calculator, you could just say b equals the square root of 155. Joe leans a 10-foot ladder against a wall to clean a window. If the base of the ladder is 6 feet away from the wall, how high up the wall does the ladder reach? If necessary, round to the nearest tenth. So let's first draw a diagram in order to understand this problem better. Joe has a 10-foot ladder and he's leaning it. So that's going to be our 10-foot ladder. And the base of the ladder is 6 feet away from the wall. So here's the wall, and the base is 6 feet away. So how high up the wall does the ladder reach? So we're wondering how high up does it reach? So this is a leg that we're looking for. So we're going to go back to our Pythagorean theorem, a squared plus b squared equals c squared. Our c is the ladder, that's 10 squared. We can say that a is 6, and we're looking for b. 6 times 6 is 36 plus b squared equals 100. Subtract 36 from both sides, and b squared equals 64. And b equals the square root of 64, which is a round 8, a perfect square. So how high up the wall does the ladder reach? It reaches 8 feet up the wall. Determine whether the given lengths can be the sides of a right triangle. We're going to use the Pythagorean theorem, a squared plus b squared equals c squared. And remember that the longest side of the triangle is the hypotenuse. In this case, it would be this side. So let's accurately substitute the numbers. The leg could be 7, one of the shorter ones. The other leg could be 6, one of the shorter ones. And the hypotenuse has to be 15, the longest. 7 times 7 is 49, and 6 times 6 is 36. And 15 times 15 is 225. Well, of course, 49 plus 36 is much smaller than 225, so it does not equal 225. So let's explain. No, the lengths are not a right triangle, are not the sides of a right triangle. Because 49 plus 36 does not equal 225. A tent has an adjustable center pole. A rope is 17 feet long and connects the top of the pole to a peg 8 feet from the bottom of the pole. How high should the center pole be adjusted? With problems like this, it's very helpful to draw a diagram. Let's draw our center pole here. A rope is 17 feet long and connects the top of the pole to a peg. All right, so here's our peg. The rope connects the top to a peg, which is 7 feet. That rope is 17 feet long. And the peg is 8 feet from the bottom of the pole. And we want to see how high we should adjust this center pole here. So using the Pythagorean theorem, a squared plus b squared equals c squared, we know that the pole is standing straight up, creating a 90-degree angle. So the longest side is always the side across from the 90-degree angle, and in this case it's going to be 17. We could say we're looking for the height of the pole b squared. You could call that a squared as well, but we know the other leg is 8 feet. 64 plus b squared equals, let's find 17 times 17. 289. Now to solve for b squared, we need to isolate b squared. So we're going to use the inverse operation of adding 64 and subtract 64. b squared equals 9 minus 4 is 5, 8 minus 6 is 2, and 2. So the square root of 225 equals b, a single b, and b equals 15. So the pole needs to be 15 feet high. Thank you for watching educator.com.